Right, so as I said, the topic for today, we are discussing sigma notation, trying to understand what are we talking about there, and what do we actually have on sigma notation. So sigma notation, we're adding, it's just another way, a short way of saying add something. For example, if we can remember previous examples that we had, I once gave you something like 5 plus 7 plus 9, and then I said plus plus plus, right? And then that's what we had. Now what sigma notation is to say, remember in this question here, I would give you like this, and then maybe I can give you the last term. Let's just say the last term is 11, 13, 15, 17. Let's just say it's 17 here, so we have plus 17. If we have something like this, what I've given you there is the last term. That 17 is the last term, isn't it? So because it is the last term, the question, remember in previously we said calculate the sum. I could have also asked you this question in this way. I could just write the following, and then I put the equation, the rule in here, meaning the Tn in here. Then I say start from here, start from there, and then I say end from there. So what this thing is saying is that this elongated sign here, that weird looking symbol, says add. Okay, it says add the terms in the series. That's what it's saying. It's saying add the terms in the series described, right? So that series in the series described by the rule in the brackets. Add brackets. Add the terms in the series described by this rule, meaning that add the terms that are found by using that nth term there. Right, so add the terms in that series from this value, from this position, you can say from this position to that position. That is what it is saying there. Add the terms in the series described by this general rule, that is, the rule is written in the brackets, and then from that position to the other position. Okay, so that is exactly what it means there. And if you can still remember, if I want the position of that 17 there, let's take our sequence to the other side, and we're going to work on this and write it in sigma notation. So if I were to write this thing in sigma notation, first of all, I must find out what position is this term. And to get that position, I must find out whether this is geometric or arithmetic. So if I say 7 minus 5, I get 2. 9 minus 7, I get 2. So that tells me that I'm dealing with an arithmetic. Since I'm dealing with an arithmetic now, I need to find the general term of that arithmetic. We can say it is Tn is equals to A plus n minus 1d. Remember, from this we know that this is our d, and then we know that this is our what? Our A. So therefore that means the general term is 5 plus n minus 1 with a difference of 2. This is the general term. Then you can simplify the general term by saying 5 plus 2n minus 2 by multiplying the 2 inside, and then after that we can say you have 5 minus 2, so you have 2n plus 3 as your Tn. Okay, as your Tn. So that is going to be your general term. Now since that is the general term, I can now find out what position is 17 by substituting Tn as 17, because remember Tn stands for the term in a certain position. So that term is 17, and then we do not know the position. We don't know n, the position of that term. Then you'd say 17 minus 3 equals to 2n. You should get 14 is equals to 2n. You divide by 2. That means your n is 7. That means that this is in the 7th position. So how do I write whatever I'm seeing there in sigma notation? To write it in sigma notation, I'm just gonna write sigma here. You'd simply say, you know that 5 is in position 1, isn't it? So you're saying add the terms in the series described by the general rule 2n plus 3. This is the series there. The 2n plus 3 gives you the terms in the series. Now you must add those terms in that series from the term that starts in the first position to the term that ends in the 7th position. That is what we are saying there. So you have written this. It's another way of saying this. This is another way of saying that. Okay, so it is another way of saying that. So whenever you are seeing this, it means add the terms in the series described by this general formula from the term in the first position to the term in the 7th position. The term in the 7th position is 17, so add those terms from the first one to that one. Let's try to do another one. Let's say you got 2 plus 4. Let's say you have 2 plus 4 plus 6 and then plus 8 and etc. Right? And then let's just say plus 22. So let's say you have this, and then is there another way of saying this without writing 2 plus 4 plus 6 plus 8 and stuff? Or can we write this in sigma notation? Well, for you to write in sigma notation, first of all, you need to know what position is 22. And for you to know what position is 22, you need the general term. For you to know what is the general term, you need to know what the type of sequence you are working with. So if we say 4 minus 2 here, you get 2. If we say 6 minus 4, you get 2. 8 minus 6, you get 2. So from this, you are able to tell that since it's the same number, we are dealing with a what? With an arithmetic series. You are dealing with an arithmetic series. Now, since we are dealing with an arithmetic series, that tells us that this number here is going to be our difference, and then this number here is going to be our first term. So our A is 2, and then our difference is also 2. So for me to find the position of 22, I must use the formula TNA plus n minus 1 D, because this is the term for arithmetic that talks about position of a term and that talks about a term. In this formula, let's remember that Tn stands for the term. When I say term, it means these numbers here that you are seeing, those are your terms, okay? And then remember, n will stand for the position of that term, meaning that here it is in the first position, second position, third position, etc. Those ones are your values of n, while these ones here, they are values of Tn, because they are the terms. Okay, so the term is 22. We need to know the position here, so we substitute 22 here because it is a term, isn't it? So we put 22 there. Then we say, what is our A? Is the first term. We said it is 2. And then do we know the position of 22? We don't. So we just write 22 minus 1. The difference is 2. It's positive 2. So from there, oh, sorry. I think I made a mistake here. It's not 22 there, it's n. We don't know the position, is what we are looking for. So we now say 22 minus 2 equals to n minus 1 bracket 2. You're gonna get 20. Now I always tell people when they are here that to get n, you don't have to say 2n minus 2. You just have to divide by 2 both sides. If you do that, you're gonna have 10 is equals to, remember this will cancel that, you'll be left with n minus 1. So therefore your n will be 11. So what this means is that this is in the 11th position. This one is on the 11th position. Now that you know that it's in the 11th position, it means how many terms are there? It's 11 terms, isn't it? Because it is the last term, this one. That 22 is the last term. So that tells you that we are dealing with 11 terms. Because if you are the last born at home, then I ask you which how can I say this in English? At home, which number are you? I think you can say it like that. I think I know it better in Sisot. But yeah, if I say at home, what number are you? And you are the last born. You say I'm the 7th. It means at home you are 7 because you are the last born. If I ask you, then you say I'm the 8th and you are the last born. That means you are 8 at home. So similarly here, if this term here is the last term, since it is you can see it's the last one because we say plus 22, meaning we end there. So if this is the last term and it's on the 11th position, that means there are 11 terms. So for you to represent that on a on sigma notation, you would write it then like this. The rule is what? The rule, you can get it, remember it's gonna be 2. Remember the rule is your Tn, so that means we need to at least solve for Tn kancane just real quick. So Tn is 2 plus n minus 1 d. So you're gonna have 2 plus 2n minus 2. That means the rule is Tn is 2n, right? So it means inside here you write 2n. Then you start from 1 until the position 11. Then you have represented that or written that in sigma notation. So remember, the procedure is simple. Find the position of that last term, right? Then you'll be able to write that thing in sigma notation. Let's try another one. See if we can represent in sigma notation. I'm gonna give you some time to work on this one. We got 20 minus 10 minus 40 minus, then we have dot dot dot, and then we have minus 490, right? Can you represent that in sigma notation? Write this series in sigma notation. So I'm just gonna give you at least 4 minutes at least to do that, and then we can look at it. So for us to write the following in sigma notation, right, we need to find what we call the last term. We need to find its position, right? But for us to do that, remember we need to identify what type of series we're working with. So remember I said the last time, you take this as a term, as like that negative 10, you take it as a term. And reason being, remember I told you that actually for it to become like this, it first started like this. It was 20 plus negative 10, and then plus negative 40, and then plus a negative number, right, like that, and then plus this negative 490. So now they write it as just minus, because remember, when you say series, you think of addition. Let's be honest, if I say to you a series, you must be thinking about addition, because we are adding the terms in the sequence. A series is when you are adding the terms. So if you find yourself having minus, 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 it is still a series. It's just that now they were adding negative numbers. So because you are adding negative numbers, it affects the sign here, because now positive times negative becomes what? Becomes negative. So they just write it as negative. They don't write plus negative 10. Same thing here. Understand? So that's why I say you take it as a term. This is a term. So this is a term. Same as this. It is a term again. Same as this. It is also a what? A term. Same as this. It's your term. So now that we know those are our terms there, for us to check whether this thing is arithmetic, remember it could be also geometric, but you must just check. I'm gonna start with checking whether it's arithmetic. So to check that, you say negative 10 minus 20, meaning the term on the right minus the term on the left, you get that you have negative 30. And then here, negative 40 minus negative 10, you find that the answer is negative 30. Same thing, same thing. So that means since you are adding, since this number is the same, that means that is your constant difference. It means this thing is an arithmetic because you are adding the same number to get to the next term. So since it's arithmetic, already we know that this formula applies because this is for formula for arithmetic. And because it applies, we can now substitute, okay? Let's actually get the general term. Why am I saying let's get the general term? Because in sigma notation, remember, we will have to put the general term inside here. So let's already get the general term. So the first term is 20. We're gonna say 20 plus n, we'll just leave it as n, and then the difference is negative 30. Remember, this is your difference, this is your a, this is d here. So from there, when you simplify, you're gonna have 20 minus 30n plus 30. So therefore, your Tn is going to be what? It's going to be 50 minus 30n. So this is the general term of the sequence. Now, since that is the general term, we also need to know the position of this one. So we can substitute it as a term there and then solve for its position, meaning we solve for n to get the position. So you can take the 50 to the other side. Remember that when you take 50 to this side, it's going to change the sign to minus 50. Okay, then here you have negative 30n. So from there, that is going to be negative 540. Then you can divide by negative 30 both sides. So I believe you'll get your n as this, cancel that. 3 into 54. 3 into 5 is 1, right? And then 3 into 24 is what? 6, 12 is what? 3, 6, 9, 12, 15, 18, 20, 24. It's 8, ne? Yeah, it's 8. So our n is gonna be 8. So the position of negative 490 is what? Is 18. So that means this is in the 18th position. So for us now to write it in sigma notation, we then say, therefore in sigma notation, it's going to be it's going to be 50 minus 30n, and then here you're gonna have n is equals to 1. We are starting on the first term until which term? Until the 18th term. So that's how you write it in sigma notation. Right, I hope that we're getting this so far. It's just a matter of having your general term, finding the position, and then writing the sigma notation. Now, let's just say you have the following now. 5 plus 5 over 2, and then plus 5 over 4. They say write this in sigma notation. What would you do? So same procedure, ne? But the only problem is this here. The only difference with this problem and the others that we did is that on this problem there is no last term. So you don't know what is the last term here. You just know the first, second and third. Whereas in the other ones I was giving you the last term. Here I was giving you the last term. So how do we deal with this one? How do we write it as in sigma notation? The question will just say write this in sigma notation. Write this in sigma notation. So for you to write that in sigma notation is very simple. Remember, you need to find, the procedure does not change. You need to find either your constant ratio or your constant difference so that you can have the general term, right? You need to find the Tn of the pattern. So for me to know whether I should use this Tn is equals to n minus 1d, or I should use Tn is equals to Arn minus 1, for me to know which one applies here, I need to ensure that I check whether the series is geometric or arithmetic. Okay, I need to check whether the series is arithmetic or it is what? Geometric. That's when I will know which formula to use. So for me to check for that, what do I simply do? I'm gonna start with right minus left, meaning that I'm gonna start by checking whether it's arithmetic. So I'll just check these two terms that are following each other. Okay, I'll just check those two terms which are following each other. Now I'm gonna say 5 over 2 minus 5. What is 5 over 2 minus 5? Right, I might not have a calculator easily accessible with me. I would highly appreciate if someone maybe could just shout the answer for me. 5 over 2 minus 5 is what? So it's negative 5 over 2. Thank you so much. And then here, 5 over 4 minus 5 over 2. This one is what?
Negative 5 over 4.
So it's negative 5 over 4. Okay. So since it gives me negative 5 over 4, these numbers are not the same. That immediately tells me that no, this is not an arithmetic. So what I'm gonna do, I'm gonna take the whole idea of it being arithmetic. We're just gonna take this and then we quickly throw it away. We throw that idea away. So what we can now try to check is that is this thing geometric? Remember, if it's not arithmetic, it has to be geometric in terms of series, but in terms of sequence, we can also have quadratic. So instead of saying right minus left, I'm instead going to try right divide by left. So now I'm going to try 5 over 2 divided by 5. So that one I think I can do mentally. It's what I think it's gonna be half. And then if you say 5 over 2 divided by 5 over 4, that is also gonna give you a half. So therefore, since this number is the same and we got it by saying right divided by left, or by saying T2 over T1 and then T3 over T2, and we found that they are equal, therefore it's geometric. Okay, and therefore our R is gonna be half and our first term is gonna be 5. Now the next code is to get the Tn now. So to then get the Tn, we can say since A is 5, we put 5 there, our R is a half, and then we say to the power of n minus 1. That is your Tn. And now that you have your Tn now, what do you need to do next? Now we need to represent this on a sigma notation. So we then say, okay, the rule is 5 times a half to the power of n minus 1, of which you can simply write it without these brackets. It's still fine. So remember, this is our rule here. And then we are going to start from n is equals to 1, meaning from the first term. But do we know where we are ending? We don't know where we are ending, so we're just gonna say until n is equals to n. So we're just gonna write n only. So in that way you will be done. In that way you would be done. Yeah? So that's how we solve it there. Okay, so good people, I hope that you understand how to write something as a in sigma notation. If you don't know what is the last term, you just write n, and it's not limited to n, good people. We can also be using other letters. If I want, I can decide to be writing k there, but I must use k throughout, meaning here I must write k, right here on that one I must write k, and then here I must also make sure that I write k, and then here I must also make sure that I write what k, and then here also k, and then here also what you also write k there. Same thing here, you would write k. So that is if you are choosing to use a different letter. We must just write that, so it would be those parts that are changing on the equations. Even here we would be talking about k. Okay, so let's do the next one. Also just trying to represent in sigma notation, right? For now we're just gonna be discussing those. So here's what we have. We have ourselves a 2. What if they write 2 and then they say negative 6 and then plus 18 and then minus 54 plus then they say 2 n terms. In fact, yeah, 2 n terms. This question is still similar to the one I did before because we don't have the last term, because you are just told that 2 n terms. So how do you find how do you write it in sigma notation? Remember, you need to find out what type of series you are dealing with. Is it arithmetic or is it geometric? So now, to find that out is not really a train smash. What do you need to do? Remember that this is a series. Even though they can write minus plus, it's a series. Actually, everything is being added there. Those minus, take it as a term. I'm gonna repeat again that it's because it started like this. You see, so it is negative 6. The second term is indeed negative 6. Just that now, because positive times negative is negative, they just write minus 6. Okay. So now, so hence we need to treat that negative 6, that negative 54 as a term. Now I'm going to check whether this thing is arithmetic or it's geometric. And for us to do that, good people, remember you're going to say the term on the right minus the one on the left. So you say negative 6 minus 2. You get negative 8. You say 18 minus negative 6. You see I'm using brackets, right? We're going to get the answer is 24. So these numbers already I can see that they are not the same. It means it's not arithmetic. Okay, it's not. So because it's not arithmetic, we can then try to check whether it's geometric. And for us to do so, you will then say negative 6 divided by 2. The answer is going to be negative 3. And then here you say 18 divided by negative 6. The answer is going to be negative 3. So therefore this becomes your ratio. So your ratio is negative 3. Your first term is 2. From that you can find your Tn by using this formula. Then from there your A is 2, isn't it? Your R is negative 3, isn't it? And then you have n minus 1. So because of this, you would have already found your what? Your Tn. So therefore now in sigma notation, that thing will be written as, this whole thing will be written as 2 into negative 3 to the power of n minus 1 from the first one to n terms. So that will be how it's written in sigma. So remember, if it's n on top, that means we don't know how many terms we are adding because we don't know the last term. Okay, I hope that is clear. So I just am not getting. There are some questions I need. Perfect. Here it is. Oh, thank goodness. So let's just say, right, I had the following. I had 3. I had 4 plus 7 plus 10, and then plus and then is equals to. This is the question I wanted. Now, if you have something like this, good people, how is this question different from the ones we were doing before? Is there anyone who's brave enough? Maybe.
It's adding, it's the total, the equals to it's the total of the sequence.
Wow, great. Thank you so much, ma'am. So this is the total of the sequence, meaning that it is the sum of terms in the sequence. Terms in the sequence. So it is a sum because they are saying to you when they are adding these terms, the sum is 650. But my question is, do you know how many terms were added to get that 650? No, we don't know how many terms were added. So that is why that 650, we write it like this. We say it is Sn is equals to 650. What does this mean? This means I do not know how many terms, right? I don't know how many terms were added to get what? 650. But I know that the sum of those terms is 650, right? Then from there now, if you are given the sum, do you remember that last time when I was giving you the last term, you were able to find out how many terms there are in the sequence? So similarly, if I give you the sum, you are also able to get how many terms are in the sequence. How? It's very beautiful. Let's start here first to identify what type of sequence you are dealing with, series you are dealing with. So to get that, you then say 4 minus 7, 7 minus 4, the answer is going to be 3, and then you say 10 minus 7, the answer is going to be 3. So now that we have 3 and 3, therefore that means you are dealing with an arithmetic whereby the difference is 3, our first term is 4. But now the formula that I'm going to use to find out how many terms are actually here is this one, is the formula for sum, because I'm given the sum. Why am I using this formula? Sn n over 2 2a plus n minus 1 d instead of Sn is equals to a Rn minus 1 all over R minus 1. I'm not using this one because it's not a geometric sequence, so hence I'm using the one on top. But why am I not using Tn is equals to a plus n minus 1d? This only applies if I'm given the last term, of which I'm not given. Remember, if I'm given the last term, I was using this to get how many terms we have. I think I was solving it here. I was substituting the term, then I got the position. But here I'm not given the last term, I'm given the sum. That is exactly why I use this. I always say in maths, you must always ask yourself questions why you are doing things. So the sum given there, remember it was how much? The sum given is 650. So it is our Sn, right? Then I say it's equal to n. What is the n in the sum formula? The n is the number of terms. So if I can get that n, it means I'll know how many terms were added to get 650. So we say n over 2, then we have 2 into a, which is 4, plus n minus 1 d. So from there I can quickly solve this. I'm hoping I'll quickly solve it. Wait, the difference is there. Why did I write d? The difference is 3, ne? We're adding 3. So what you can do, I can multiply by 2 both sides. If I multiply by 2 both sides there, the art of solving now. If I multiply by 2 both sides, this 2 is gonna cancel that 2. It's not gonna cancel inside, it's only gonna cancel this one because they are separated by a multiplication sign. Okay, because there's multiply in between. I hope you get me. Yeah, so 650 times 2, what would be the answer there now? 650 times 2, 13,000. 1300, right? Then we are left with n. Inside, 2 times 4 is 8. 3 times n is 3n. 3 times negative 1 is negative 3. So you're gonna have 1300 is equals to n into 8 minus 3 is 5, so you have 5 plus 3n. Right. So now you can say what you call 1300 is equals to 5n plus 3n squared. So I multiplied the n inside there. Then now it becomes a quadratic. I know we don't really like quadratic. Trust me, you are just like me. So, but then we use the quadratic formula then. So, if we use the quadratic formula, we have 3n squared plus 5n. Then we have minus 1300. So the answer will be our n will be equal to 20, or our n will be equal to negative 21,67. So remember that n can be negative, so this we say it's not a solution. So our n is 20. So what does this n mean? This means we should be happy and celebrating, we should be very, very happy because now we know how many terms there are. Therefore, this means they added 20 terms, right? Let me write it in Zulu. Means they added 20 terms in the series. They added 20 terms in the series to get 650. Would you look at that? They added 20 terms in the series to get 650, which is beautiful. So now that you know that they added 20, now you can write this in sigma. Oh goodness, it's gonna be a bit of a lot. We are not done. Remember, we need to write this in sigma. The sad thing about sigma is that you need Tn. Here we know that we are starting from 1 until position 20 because it's 20 terms. But then inside there now, we need the Tn. So to get the Tn, we'll have to use remember, we have to use Tn is equals to a plus n minus 1d. So I'm just going to take a and d. A is 4, d is 3. A is 4, d is 3. So I can now say Tn is equals to a plus n minus 1d. Tn is equals to a, which is 4, plus n minus 1. The difference is 3. So your Tn will be 4 plus 3n minus 3. Therefore your Tn will be equal to 3n plus 1. So therefore in sigma notation, you would write 3n plus 1. You add from the first one until the 20th. Then you'll be done. Quite a lot of work. Too much work. So that's what we're doing there. I'm hoping that it's becoming clear how to write things in sigma notation. I'm hoping that it's becoming clear how to find the number of terms that were added to get a sum, how to find the position, of a term given the term in the series. I'm hoping that it is clear how to work with sum formula and TN formula for arithmetic and for geometric, good people. The goal is to master these things so that you can do advanced problems, so that you are ready for any question you're gonna be asked. Good people, I have so many advanced problems you're gonna be doing here, but my way of teaching is that we must go a bit, basic first. So please have patience a bit. I know some of you are dying to get those those big chunks. Good people, I have so many questions that will be asking you how many terms between 4 and 500 will be there that are divisible by 11. Those type of questions, good people, like can you add all the odd numbers that are divisible by 5? You see? So we are coming to those. Let's just start basic and understand the basic principles. Get comfortable with working with the sum formula. Get comfortable with working with the TN formula. Know when I apply it, when you apply it. Know also now how to put these things in sigma notation. This is a basic sigma notation question. The reason why you need to write a series in sigma is because now questions are going to come written in sigma notation. So for example, now questions are going to be like evaluate. They're going to be like this. Then as they are like that, then they tell you to say find the value of n. Okay, so when questions come like that now, you must understand first what is sigma, and then where does it come from, and the likes. Okay, so speaking of which, good people, you can't say I know how to drive a car if you only know how to go forward. You must also know how to reverse. That's when you know how to drive a car. In the same way, here, what if I gave you this and then I was looking for the value of n? How would you get the value of n? Is there anyone who has an idea what we can do here to find the value of n? So to find the value of n there, you need to go back in reverse. So that means you would need to understand what you are given first. Okay, so let me not cover that for today. Let me just leave it as a scope for the next session. We're going to be dealing with these type of problems on our next session. These type of problems, dealing with sigma. Then after that, we'll then do with word problems. So what is left is sigma and word problems. So as you write the next test, try to attempt that test. It will be asking about these questions that we're dealing with so far, about sum, finding sum, finding the number of terms. Then I'm gonna add also some of the nice ones, like for which values of n is the Sn going to be greater than maybe 500. I'm just gonna add these as part of preparation. Then when you commit next time, we'll discuss sigma. Then we discuss word problems. To consolidate sequences and series, we need to finish with it and go to the next one. Okay, so